Okay, students, we have another example which we'll try to prove that after interchanging rows and columns, the value of the determinant remains unchanged. So suppose there is a matrix A 3 minus 5 2 4 0 minus 1 0 0 1. I'll take its determinant A. So its determinant will be in the form of two vertical bars, then putting all the elements 3 5 minus 2 3 minus 5 2, then 4 0 minus 1, then 0 0 1. Let us calculate the value of the determinant. As we have discussed earlier, it is better to calculate the value of the determinant along that particular row or column in which there are minimum number of non-zero elements. Of course, this particular row and this particular column, they have minimum number of zeros, but we have to choose that particular row or column in which there are more number of zeros. Like for example, the third row is having 2 zeros, or we can say the second column is having 2 zeros. So we can opt along anything. So it's better, let's go with third row. So the first particular minor determinant will be 0. Second determinant, as we always write 0, 0 and 1, then there is no meaning in writing the supporting determinant with this. But still, if you want, you can write it. Here also you can write the minor determinants. Here also you can write the minor determinant. But here, according to the signature, according to the system of signs, we can say that here it is plus, minus, plus, minus, plus, minus, then plus, minus, plus. So according to this, the last particular row, plus, minus, plus. So this will be plus sign, this will be minus sign, and this will be again plus sign after this plus sign. So I am not going to write this particular two minor determinants. That you will write, okay, and check whether they are going to 0, because they are going to become 0 for sure, because 0 is the element to multiply with minor determinants. Now only this element will survive. 1 into the minor determinant is 3 minus 5 4 0. 3 minus 5 4 0. So determinant of A is nothing but 3 into 0 is 0, minus 5 into 4 is minus 20. So minus of minus 20 is plus 20. So I've got determinant A as plus 20. Now if I try to calculate, if I try to find out A transpose, that means I am trying to interchange the rows and columns. So I will write the first row will become first column, 3 5 minus 2, 3 minus 5 2. Here 4 0 minus 1, which is second row. Now it is going to become the second column, 4 0 minus 1. Now third row 4 0 1, sorry 0 0 1, here going to become the third column, 0 0 1. So now I am going to calculate the value of the determinant of A transpose. So very clear, you can calculate its determinant. So let us write the two vertical bars. Here it is 3 4 0 minus 5 0 0 and 2 minus 1 1. So if you want to calculate, again we will have to see which row or which column has minimum number of non-zero elements or maximum number of zeros. Suppose if we see here, we have got second row as maximum number of zeros and third column as maximum number of zeros. So let us calculate by the third column. So what are the elements? 0 0 1. So I will write 0, then I will write 0, another 0 and 1. Now I will see what is the signs of what are the signatures. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So the last column is having the signature plus, minus, plus. So here it is plus, here it is minus, here it is plus. Now since there is no meaning in writing these determinants, so I am going to skip again these two minor determinants, but certainly I will write this determinant which is acting as a minor determinant for element 1. So what is the minor determinant of element 1? We have to hide this row and this column. So 3, 4, minus 5, 0. So I will write 3, I'll write 4, I'll write minus 5, I'll write 0. Okay, so still then also I am getting the same value, that is 3 into 0, 0, minus 4 into minus 5, that is 4 into minus 5 will be minus 20, but since already minus sign will be there in between, so it will become 20. So we have seen with the help of another example that how we get same value even if we interchange rows and columns of determinant. This property is very important, very helpful in dealing with different kinds of proofs and problems and equations while dealing with determinants. Okay, so once again I repeat that the value of the determinant remains unchanged or remains same if its rows and columns are interchanged. Or in other words, the value of the determinant of a matrix is same as the value of the determinant of its transpose. Okay.